Welcome to this special episode of Frequency Matters, the RF Microwave Update series. I'm Pat Hindle, and today I'm talking with Keith Benson, Director of RF and Microwave Amplifier and Phased Array IC Products at Analog Devices. Welcome, Keith.
Thanks for having me.
So you're involved in many of the IC products at ADI, so I thought it'd be great to get your outlook on some of the market trends and technology. What are some of the overall trends that you're seeing in the market for your products?
I think we're seeing customers choose products that are generally easy to use, more integrated with smaller form factors. I don't think this is unique to RF amplifiers. These are general trends across the industry, and we see the same things on these products. I think we also see customers want to digitize more of the spectrum instantaneously, and that's certainly the direction of our data converter products. So we're trying to help facilitate that goal with our products as well. Then I think with phased array antenna, we often see customers trying to ask us for help with their overall system solution for phased array antenna. So we try to help, maybe offer more integrated products or small form factor products to help with a lot of phased array antenna solutions as well.
Does Analog Devices, being a leading supplier of data converters and non-RF components, does that shape your design for RF front ends, and is it benefit to the end applications and markets? Do you find synergy there?
Yeah, I think this is one of the biggest benefits that we're able to bring to the marketplace. Looking ahead, these systems will become more integrated, more direct conversion, less of the superhead architectures that would have had more frequency planning options with various components. So with Analog Devices being able to offer more of a complete signal chain, we're able to look at all the components 4 to 5 years in the future and try to shape the signal chain in the front end altogether to have a more of a complete system solution. And I think, what the value proposition there is that we can offer a complete solution to our customers from the baseband to the antenna with the power around it and say, hey, here's your solution. You can go off and now design the software and algorithms to ride on top of the hardware and focus on the problems that they want to be solving. So in the end, it becomes more of a software-defined radio solution, which is a lot of customers' goal.
And what aspects or value does Analog Devices bring to the customer and the market for GaN and GaAs RF front ends?
I think in general, we want to lead with performance. Hopefully customers, when they think of Analog Devices, they think of industry-leading performance. I think we're pretty well recognized with gallium arsenide low noise and power amplifier products, with gallium arsenide and SOI-based switch products. I think we made a lot of progress with gallium nitride-based products over the last few years, and I think customers will see and hear a lot more about our GaN-based products in the next few years. And these days, customers often come to us with more of a complete solution requirement. So we may be combining multiple semiconductors at the package level and have more of a complete solution and architect that solution to mate well with the signal chain around it, that we may also offer those components. So in the end, we can provide them more of a complete solution so that they can get to the software and algorithms faster and more onto their system level solutions.
What factors do you consider when you're choosing a semiconductor platform? What goes into that decision?
I think the first thing we may think about is about the cost. Is there a certain cost target with a requirement that would push us more of a silicon-based solution? Gallium nitride today is still largely 4-inch based wafers. Gallium arsenide is still largely 6-inch based wafers. So if you really want to get the economies of scale of a 12-inch wafer, you'd push towards silicon. So I think that would probably be the first consideration. Is there a benefit to using silicon from a cost perspective? Then next, I think we look at performance. Is there something about the requirement that has a really high power density aspect to it that might push us towards gallium nitride? Is there something about the requirement that would have a SPI interface or a memory that's included to it? We maybe look towards silicon. Or if there's something with a low noise figure requirement or high linearity in the receive that may push us towards gallium arsenide. And then, like we've talked about, if there's more of a complete solution requirement where we maybe combine multiple semiconductors at the package level, we may be looking more of like at a SIP solution where we can solve more of the problem for the customer. So I think those are some of the things we think about when we look at the different technologies and where we combine at the IC level, or we combine at the package level, and how much is the right mix for the requirement.
And there's been a large push for GaN for power amplifiers. Do you see a day when gallium arsenide will become obsolete?
Yeah, I think GaN is a great technology. What it's able to do with solving high power density requirements is great compared to what gallium arsenide is able to do. I think trying to combine 32 or 64 gallium arsenide PAs to try to make a 50 or 100 watt PA, those days are probably over. What GaN can do compared to gallium arsenide and trying to make high power density is much more efficient and easy than what would have been done with gallium arsenide in the past. So I think for high power amplifiers, generally over 2 or 4 watts, those are probably moving towards gallium nitride. For driver amplifiers, I think there may be still some benefits with gallium arsenide in terms of cost and linearity. There may be some benefits with gallium nitride with a common supply rail between the driver stage and the output stage. So there might be pros and cons between GaN and GaAs for the driver stage. I think more of my interest over the next 5 to 10 years might be to see how silicon progresses. There's already been so much improvement with silicon-based processes, so it'll be interesting to see what the integration benefits of silicon brings and how much of the gallium arsenide world it can take over as the silicon processes continue to advance over the next 5 to 10 years. And then on the consumer side, where a lot of the wafer volume for gallium arsenide is in the handsets, there's new pushes into GaN on silicon, and can that try to meet a cost target and efficiency targets that would make it attractive over gallium arsenide for handsets. So I think some of those things are still unfolding. So we'll see how that progresses over the next couple of years. But I think in short, there's still some years to run with gallium arsenide, but there's also a good technology that's coming in other places. So it'll be a good fight over the next handful of years.
Well, thank you, Keith, very much for all the insights in the RFIC markets and those trends. To our audience, you can find more videos at videos.microwavejournal.com. Thanks for watching.